Hey guys, and today we're going to be going over how to make a deck of cards. And before we get into it, please click the subscribe button, check out the Discord if you're interested and have some questions. I noticed that only negative 15% of you are subscribed, so just a little reminder. Anyways, so let's start with this. This is just a warning right off the bat. It's going to be boring-ish, unless you're interested in this, right? So it's going to be heavily data pack oriented. It's going to require 0 entities, and it's going to be very efficient and fast, but it's also going to be very text heavy, lots of commands, lots of topics. So we're going to be doing that. Just a warning from the get-go, let you know what you're in for. But what you get out of this is a way to handle any game that has cards in it. And I'm not just talking, suits and numbers. I'm talking Uno, which I made before. I'm talking any game that has cards. So we're just going to be going over all of the bare essential needs to handle a deck. And it's going to be very multiplayer friendly, very oriented towards not having bugs. So from the get-go, we're going to start with making a deck. And we have cards. I'm going to do deck, okay. Or I guess I'll just leave it in the plain namespace since we have cards here. So let's go into init. We're going to need quite a bit of things. So let's go ahead and do scoreboard, objectives, add deck dummy. And this will hold a lot of fake players that have to do with our deck. And then we're also going to, we probably don't need main ever, but we're gonna have to create a deck. So let's go ahead and make a function called new deck. And for our sake, I'm going to make a deck of cards that is very simple and small. So I'm going to do data, modify, storage, cards, deck, set, append value. So we're going to build it by appending, and we're going to append some elements to an array essentially. So these elements are going to tell you stuff about the card. So with Uno, it matters what color it is, what type of card it is. Is it a number? Is it a switch? Is it a skip? Those are important to that. For us, we're just going to say number, and we're going to give it a number. And suit, and we'll give it a suit. So suit, we can give ourselves some information here. Suit is going to be 1, 2, 3, 4, and that is hearts, spades, clubs, diamonds. And number is going to be 1 to 13, ace to king. And I'm not going to do all the cards. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll have 4 for each suit, just 3 for each suit, just for the sake of inclusivity. But I'm not doing the full deck. This can easily be expanded to the full deck. That's the great thing about this system. And we're going to do that. And we're also going to cover a lot of essentials for handling arrays. So that's also going to be a big thing we're going to cover here. So let's go ahead and, let's just go through the gambit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And I guess we don't have a king here, so I will add an extra card just for the sake of having a king. So here's our deck. It's as easy as that. Now we just have to do data, remove storage, cards deck at the beginning. That way it'll clear it. So when we type reload, we can do function, cards, new deck. And now when we do data get storage, cards, deck, it'll give us this array of values. So now it comes into the theory of how to handle it, right? So the way that I have it set up, the way that I do it, is you have your deck, okay? Then you have your hand, and then you have your discard. And these are 3 separate arrays that are handled in a very special way. But what it does is it sets up a system so that if a player leaves the game with cards in their hand and then they return, they can still play. If they leave the game, they don't come back, you're not going to lose any cards. So the only time you have to play new deck is one time when you start the world, and then you can just keep playing off the same deck. You shuffle it each time, it gets mixed up each time. You don't have to reset the deck every game. So this system is pretty nice. So you have 3 arrays, and I'll go over exactly how each array is handled. So when a player grabs a card, so I guess we'll handle this. So let's go draw a card. We'll handle shuffling at the end. I'm just going to throw it in and wave my hands because that is going to be probably one of the longest parts, or maybe I'll go over it depending on time. So let's go over draw card. Okay, so this will just draw a card off the top of the deck. So what this will do is we're going to do data, modify, storage, cards, hand. So we go from deck to hand, and that means that this card is in somebody's hand. It doesn't mean it's in my hand. It's in somebody's hand, anybody. And we're going to set, we are going to append from, or really I think prepend would be best, but I'll do append for now. The order does kind of matter, but not really. Append from storage cards deck at 0. So this will be taking the card from the top of the deck. And then we're going to do data remove storage cards deck at 0. So this is going to take it, move it to hand, and let's do it, call it hands. And then it'll take it off the deck. So that's how you draw a card. And what this means is that somebody has it. How you represent who has what card is really up to you. So you can do that by having player-based data storage and then displaying it that way. Or you could do that by giving players items like a carrot on a stick that represents a card. However you want, but you don't want the players to lose those cards because then you might come into some problems. However you want to handle it. I've seen it handled with like players have the data and then it's displayed in the hotbar what card they have, which is kind of cool. But that's extra work that I'm not going to cover. That's not having to do with the deck. That's how you display the card. So right here, you would add stuff to give this card to player. You would do that before you delete it. But we're going to assume that since I'm the only one here, it doesn't matter who has it. So we know everything in the hands is what I have. All right, so that's how you draw a card. Now, how do you place a card? How do you play something or discard per se? So let's call it discard card, because some games you just discard them, you don't play it, so to speak. And you might want to have an extra data storage for whatever card is in play. In practice, most of the time, like for most games, whatever the top of this discard is the card that you operate on. Or maybe if you're playing something like Texas, like 21. If you're playing 21, then you don't discard till like the end or when you're out. So you would just discard all of their cards. So we're going to assume that you have some way to figure out which card they have. So I'm going to just do it based off of a scoreboard. So so what you'll need to do is you'll need to load a score onto a scoreboard. So let's add some fake things. Scoreboard players add dot number deck 0. And when you add 0, it does nothing to it, just lets you know that it's there. And suit. So these scoreboards are going to be kind of like a save spot. Okay, so now we're going to do execute store result storage cards temp, and temp is going to be useful a lot. And let's do scoreboard players, data modify storage cards temp, and we're just going to remove it actually. So we're going to clear this before we hop into it. So we're going to set the temp, make it an integer, make it a 1.0, and do temp dot numbers, run scoreboard players get dot numbers card deck. Okay, so this will load numbers onto numbers and suit onto suit. So we have number and suit, number and suit, number and suit. Okay, so that loads number and suit. Now we have to basically run a function called function cards. All right, and this discard is going to be, we're going to do probably cards, and then we're going to go hands / goto. Okay, so this is going to be called hands goto, and then we're going to do return. So what we're going to handle here essentially, and I'll give you some visual representation, is we have a desired card we're looking for. So hands is going to cycle. It's going to assume that the card is in the deck. So hands is going to cycle until this card is in the front of hands. Then return is going to cycle until it's back where it was before. Of course, return isn't necessarily useful for hand since hand's order doesn't matter, but this may be useful for other things if you're trying to search. So, but we'll just do go to for now, because I guess if it cycles back, that doesn't really matter. So let's go hands, and let's do go to. Okay, so in goto, it's going to essentially loop. So we're going to do execute store success score dot bool deck run data modify storage temp1 set from storage temp. Okay, so this basically is a way to check if temp is equal to temp1, and we're going to set temp1 from hands at 0. So we're going to take the first thing on hands, check is it the same as temp1. So if this shows up as a 1, it was able to copy this data, which means that they are not the same. If it's a 0, then they copied the data. It couldn't copy the data, which means they are the same. And I covered this in a previous video. Okay, so execute if score.bool deck matches 1, then we're going to run this guy again. Okay. All right, and we also want to go like this. So we're going to do data modify storage, and then we're going to cycle it. So hands at negative hands. Okay. And then we're going to do append value append from storage hands at 0. Okay. So what this does, and I'll zoom in. I'm sorry if that was not zoomed in enough from before. Okay. So you're going to basically put the first thing onto the end of hands, and then you're going to remove the first thing. Data remove storage hands at 0. Boom. Okay, so what this will do is it'll keep cycling until the first thing is equal to the correct is equal. It'll keep cycling till the last thing is equal. But that's fine, because first and last we can handle. So we know that the last thing on the array is going to be the same. So then we can go data, modify, storage, discard at append from storage hands at -1. So -1 means the last thing. So this will keep cycling and go 1 past it, and then -1 we'll take it from the end. And then we'll do data, remove, storage, hands at -1. So this is going to move from the discard to from the hands to the discard. So I'll add some extra code here that will say mess with hands at -1. No. We can just go back up here. So this is just for discard. So you would want to do something based on the scores set up here, probably, if you were making the card do something when you discard it. So let's go ahead and do reload. We're going to get the storage of cards. Okay, so now we're going to do function cards. So function cards draw card. Okay, so there's something wrong with draw card. So let's go here. That is correct. Let's go here. That is correct. Okay, I guess the reload is taking some time. Let's go ahead and pull up the debugger. Reload. Okay, so it had a problem with discard card. Okay, so it's having an issue with discard card at line 5. Okay, so I often forget namespaces, so I just threw them back in there, and we should be good now. Pretty much, let's see, we're still missing cards, and successfully fixed. Yeah, a lot of times I forget the name spacing. Okay, so let's go to draw card. And then if we do this data get, you're going to see we have hands has 1, 1, which was the first thing. Okay, so we're going to draw a card again. And now we have 2 of these things onto the hands and everything else on the deck. Okay, so let's go ahead and get 4. That gives us 3 numbers. And let's do 4, 5. Okay, so now we have 5 numbers. All right. So now let's do scoreboard objectives set to play sidebar card deck. Oh, function. Let's run the init function. Boo, 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 boo. Scoreboard objectives sidebar deck. Okay, so let's go ahead and discard number 3 suit 1. So slash scoreboard player set dot number deck 3 dot suit deck 1. Okay, and now let's play discard. 24 commands is what it took. And let's go ahead and evaluate what's going on. So we have discard. It discarded 3 and 1. Temp still has stuff on it. Hands has 4, 2, 5, 2, 1, 1, 2, 1. Okay, so there's no 3, 1 there. And the deck, no 3, 1 there. The only places 3, 1 is temp, and you could temp 1 and temp, and you could clear them after, or you can just clear them before you use them again. But I like to just clear them before I use them again. So we successfully moved the hands value that is dynamically set to whatever I put it in game to the discard. So now we have discard and hands. Now what we can do is then say, let's go to reset deck. So reset deck is going to be pretty simple. This is going to be where the game ended. So we need to take all the hands and we need to take all the cards. And this is really simple. So we take data, append, store, data, modify, storage, cards, deck, append, from, storage, cards, hands. Okay. So you take all the hands and you put them, and you take all the discard and you put them, and then you do data, remove, storage, cards, hands, and cards, discard. And this will just stack all the cards again. So this will put everything back to where it was. And I kind of like to do that so that we can easily see what's going on. So we have reset deck. And now if we go to data get storage cards, you're going to see only deck, and it has all of our numbers again. So you have 6, 2, 7, 8. We might have lost something. Let's see. Deck, append from, storage, cards. Okay, so to reset the deck, you just need these open and close brackets to say pick everything in the array to throw on. So let's do a new deck. Let's do a draw card, a draw card, a draw card. Okay. And now let's do a reset deck. So the number is still 13. This thing will tell us how big the deck is. We can always look at it and you'll see exactly what happened to the deck. We have the first set of 3 numbers, 1, 1, 2, 1, 3, 1 is at the end because they got on the hands and then they got thrown back on to the end. Okay, so that reset the deck. And then obviously we can do draw a card. We could do scoreboard, players, remove dot deck, size, deck 1. So now we kind of have a nice handle of what's going on without having to do the data get. It can tell us exactly how big the deck is and where it's going. And it's good to keep these little extra variables floating around. You obviously need to use the whole execute store thing when you conglomerate all the cards back and when you make a new deck. You need to do it so that you can have that value start off in the right place. But obviously, I mean, if you're drawing a card and it's doing it properly, then the remove one will be accurate. Okay, so we have a way to draw, we have a way to discard, and we have a way to reset the deck. Okay. So there's a few, let's just discuss kind of what this does for you. So you can draw a card from the deck, you can discard that card, and the cards going onto hands basically allows it. So let's say I had 3 or 4 cards, right? And I disconnect. If I reconnect, I can rejoin the game and I still have those cards, and those cards should still be in the hands array because you can't delete what isn't there, if you get what I'm saying. So if somebody else has a card that is the same card as me, there should be 2 of those elements on the hands array. So when they use that card, it'll only delete one of those elements, the first one that comes up. But mine is always going to be there, okay, for the duration of the game. but when the game ends, you cleared them. So then when I rejoin, if I join back after the game ends, then you should remove all my cards from me. I should no longer have cards. But I can still rejoin if the game hasn't ended because it still remembers what cards I had in the hands array. So this allows like very easy, you know, if somebody disconnects, they can always reconnect right away and still play the game without you having more cards added to your overall card pool than necessary. Your card size of the deck will never change as long as you handle the two factors of when somebody leaves and they join back to a game that is different, you clear all their cards. As long as you handle that, your deck should never change size and it should be persistent. Okay, well, that's pretty much everything with handling a deck of cards. I mean, that gets you everywhere. The only thing left is shuffle. Shuffle is a nightmare. I will try and do it right now for you, but it is a nightmare. So shuffle, there's so many shuffle algorithms. I have my own that I like. My shuffle algorithm is this. So we have these cards. Okay, so we're going to pick sometimes one, sometimes two, and one of these blocks represents maybe 5 cards or so. So we're going to pick sometimes 1, sometimes 2, sometimes 3, or sometimes 2, or sometimes 1. And we're going to grab this chunk and we're going to pull it out. Okay. Now we're going to pick another set. This time we'll grab 1 and we're going to pull it out. Then we're going to grab 3 and we'll pull it out. All right. So now what we're going to do is we're going to reorganize these. So randomly, I'll decide to put the 1 here and I'll decide randomly to put 3 here and 2 here. So this is, I would say, a cut the deck kind of shuffle method. This is a shuffle method. If you've ever seen somebody shuffle cards where they hold the deck and they grab some cards and they pull it out and they put it on top. It's kind of like that. It's kind of like a cut the deck. I mean, it's really just cutting the deck. You're breaking the deck into different pieces and rearranging them. So that's how we're going to shuffle. So let's go ahead and add a folder called shuffle. And then we have shuffle start. And you would only shuffle when the deck is full. So you would, if you need to shuffle, oh, we should also have, let's see, pull discard, reset discard. We also need this, which is the same as reset deck, but it doesn't handle with hands. We need that as well. So if you're mid-game, you can take the discard pile and put it back onto the deck. So you just need reset discard as well. And that's going to be important for shuffle because shuffle would happen right after you do a reset discard, you shuffle, or right when you start the game, you shuffle. All right, so we shuffle and let's do shuffle start. So give us a starting point. All right, so we need to grab some cards randomly based on the size. Okay, so this is going to be some hard coding, some not hard coding. Let's go ahead and at least I'm going to do like a 3-stage. You would want like a lot of stages, like maybe 20. I'm going to show you 3 stage. You copy paste, change numbers. All right. So let's do scoreboard players operation #temp math equals dot size deck. Okay. So we're going to grab the size of the deck and then we're going to do scoreboard players operation #temp math. And now we're going to divide it into by 3. So #3 constant. And these are two scoreboards that we haven't set up yet. So we're going to need to establish them and pull a math library real quickly. So we're going to need math. It'll be made already. So let's do constant and scoreboard players set #3 constant 3. Okay. And what I'll add as a note here is this 3 equals number of partitions. So in this case, where I showed you with the example here, that's 3 partitions. But for a big deck, you might want to go with 20 partitions. The partitions will be evenly divided among the deck, and that's what we're doing first. And we're going to need a math data pack. So I'm going to grab that real quick. So my website is linked in the description. It contains a pack called Math Lite. This guy is your best friend. It has barely anything going on in it. It's got little to nothing, but what it does is it handles RNG and square root and things like that very fast, very efficiently. And yeah, it's a super lightweight math library is essentially what it is. I use it in pretty much every project. So let me go ahead and figure out what starting function I need for math. I believe it's math z private /init. So let's do that for the load. Math z private /init. We don't really need a tick.json for this guy, so let's go ahead back into Minecraft. I'm just setting up the starting functions. We don't need a tick. So let's go back. Let's go to cards. Let's go to functions. All right, we don't need main. And that should be good enough. So let's do reload and let's do scoreboard objective sidebar math and let's work with it. So let's do scoreboard players reset star math, scoreboard players set in math 1, and this is how you use the RNG, in 1 math 4. And if I do function math RNG range, it will give me 2 4 3 1 1 4 4 4 1 2 1 1 1 2 2 4 2 4 2 4 2 2 4 2 3 3, all that stuff. You can see it's random, right? And it takes somewhere between 20 and 50 commands. 20 and 86 commands. It really just, it depends on how many times it has to loop. But that's not a lot of power because it's very simple commands. All right. So we divided into partitions of 3. Okay. So this is going to basically say how big each section would be. We can do that, or we can just essentially pick our own sizes. So if we're going to pick our own sizes, so let's go ahead and comment this off another. So you can do set sizes random order, random sizes random order, or random sizes set order. Those are like the 3 different ways you can do it. I think just random sizes random order will work for us, but you have to be careful for the case of, you have to make sure that it can never have not enough. All right, so let's do scoreboard players set in math. So the minimum boundary I think needs to be 3. Scoreboard players set in math 3. Okay. And the maximum it could grab from a group. Well, let's go with, 3 and 5. Okay. So if the worst case scenario is we get all 3s. All right. So how many times would that need to go to hit all of ours? That would have to do 4 times. So let's go with 4. Let's go with 5. Okay. So the worst case scenario would be it takes 3 sections. All right. That's good for me. If you want to reduce this number, then you have to hard code more sections. So we're saying like this, because if you have a set of 13 numbers and your smallest number is 5, smallest possible random number is 5, then the worst case scenario, you break it into 3 sections, because 3 times 5 is 15, which means that you'll have, 2 sections of 5 and 1 section that's not quite 5. All right, so we'll go 5 to 7, which means best case scenario, it only takes 2 sections to do this. All right. So then we can run the RNG. So the RNG will give us one of those 2 numbers on out randomly. Okay. So what we're going to do is we're going to pull numbers. So let's do function cards shuffle / get. And this will get based on the out. Okay. It'll load it onto a temp. So let's still go ahead and add get. Get. All right. So what this guy will do is it'll do scoreboard players remove out math 1, execute if score out math matches more than 1, run function cards shuffle get. So it'll do this over and over until out is empty. And this will tell you how many to grab. So we're going to do data modify storage cards temp set from storage cards deck at 0. Okay. And we're going to do data remove storage cards deck at 0. And instead of set, let's do append. All right. And right before we play this, let's do data remove storage cards temp, just in case, to clear it. All right. So this will load all your first 5 cards to 7 cards onto temp. Okay. Then we can basically do, and it'll delete them from the deck. Okay, so now you got to handle these things carefully so that you don't lose any cards. You need to do stuff immediately. So where does the temp go? That's kind of up to you. So yeah. So what we can do is we can decide randomly whether to put the next thing on top of the first thing. That's a nice way of shuffling. It's really up to you. The way I like to do it would be hard coding. So let's say, you'll see what I mean. So well, let's go with a simple algorithm since this is taking so long. You can come up with your own algorithms of where to put temp. But let's just go with, we're going to run another one of these between 1 and 2. It's a 50% chance. I mean, you can use a predicate for the 50% chance. That works too. Execute if score out math matches. Well, let's do a predicate. So here we are on the great MISO generator. Let's go with random chance predicate 0.5. Copy, close, okay. And boom. So if the predicate cards RNG50 succeeds, then we're going to do data modify storage append, okay? We might want to do one more step here. So execute store result dot bool deck if predicate. Okay, so this will just store it so we can do stuff to it. So if score dot bool deck matches store result score. Okay, so if this will store whether it succeeded or not onto Boolean. So if the Boolean matches 1, so it succeeded, then do all that. If it matches 0, then we're going to prepend. So what this will do is each time that it grabs cards, it's going to randomly choose, do we put it on top of the previous set of cards or on bottom of the previous set of cards? Okay, so this isn't too bad. It's not the best algorithm, but it's an interesting algorithm. So we're going to go ahead and run it once to see what happens. So let's go ahead and do a new deck so we know the order that it's supposed to be. And then we're going to do cards shuffle start. And now let's do data get storage cards. All right, so let's see what happened to temp. Temp 1 is really where everything's going. So we have temp 1, we have 1 1, 2 1, 3 1, 4 2, 5 2, 6 2, 7 2, 6 2, 7 3. Okay, so it did kind of one iteration. All right, and our deck is pretty small now. So let's do it again. Okay, so now deck is empty by now. And our temp 1 has 8 3, 9 3, 10 4, 11 4, 12 4, 13 4. Okay, so it has all the cards that it just grabbed. I think the data remove. Yeah, this data remove temp 1 is probably what messed it up. So let's go ahead and just comment that out. Let's do reload. Let's make a new deck. All right, clear everything. Let's shuffle it, and let's shuffle it. All right, so let's see what happened to cards. All right, so temp 1 should be built up now. You have 6 2, 7 3, 8 3, 9 3, 10 4, 11 4, 1 1, 2 1, 3 1, 4 2, 5 2. Deck still has some cards left, so let's do it again and see where those go. So those went on at the beginning. So you have 13 4, 12 4, 13 4, 6 2. So this is fairly random. There's some order to it because certain sections are numerically ordered. But keep in mind that with this system, your deck should never deplete. You should never run out of deck. Okay? You never run out of deck. Your deck is consistent. So each game you play, it'll shuffle some more. And it's not a bad shuffling algorithm considering that you're getting all this nice, pretty stuff. Now for start, what we just did is we did this multiple times. So we want to loop this. So let's go into our functions. Let's go to shuffle. Let's go to loop. Okay. And in loop and in start. Okay. What we can do is we can literally delete all that. Function cards shuffle loop. Then data modify storage cards deck set from storage cards temp 1. So this will just basically clear temp 1, do something to temp 1, put it onto deck. And maybe clear temp 1 afterwards because that'll be a pretty big variable. right? And clear temp as well afterwards, because that'll be a pretty big variable at that point. You're moving a lot of stuff around. All right, so then this guy is going to play himself over and over. So function execute store. We can essentially just do each time you play this. So basically we could do let's see, scoreboard players operation dot size deck minus equals out math. Okay, so we can use this up here before we shuffle, before we grab our set. We can subtract so we can see how many cards are in the deck. So execute if score dot size deck matches one or more, run function cards shuffle loop. So you're going to loop it again if there's any more cards in your deck. And that should be good. So let's go ahead and run this algorithm and see it all in action, or I guess instantaneously. So let's go ahead and do new deck. And 210 commands were run to shuffle the deck. Okay, so now let's get cards. Oh, we lost something here. Let me see. Loop. Here it is. Data remove storage temp. No, you don't want to do that. Okay, so let's go ahead and do new deck. Shuffle start. And boom. Okay, so we got 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 12, 13. Okay, that's pretty shuffled. And if you want, you can shuffle multiple times. It doesn't take that many commands. And 1, 2, 3, 4. What? We lost stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think we lost some stuff along the way. Let me go ahead and clean this up to make sure. Oh, you know what it was? It was the size. It was the size. We didn't reset the size. Okay, so afterwards we need to make sure our size is back to normal. So let's go to reset deck. We need to copy the size guy and fix this up. So let's go ahead and generate a new deck. And let's shuffle a bunch of times. And you can really do this maybe 100 times in a row, and it'll be pretty shuffled depending on how many cards you have. 11, 12, 7, 2, 3, 4, 5, 13, 1, 6, 8, 9, 10. Pretty good, pretty good. And the more times you play, the more times it'll shuffle, and there'll be some inherent shuffling from the fact of I discard a card at a different time than another player, so now it's not in the same order. All right, so you got 10, 11, 12, 7, 2, 3, 5, 13, 1, 6, 8, 9, 4. That's pretty shuffled. So when you start your game, you can just basically, like when the game starts, you can just tell it to shuffle. Like you could just tell the game to, you could just do that, right? And it'll play maybe 1,000 commands, but that's not that much. All right, so I think that's everything I wanted to cover for decks. It was a really long time. If you made it to this part of the video, you are probably only me. And I will also leave a download to this guy in the description, but it will not say the name of the download or anything involved because I don't want you guys to just take the download and run with it. Some closing thoughts on places where you need to add your own code to. So new deck, append your own deck with your own values. Does not need to be suit, does not need to be number. You can make the data anything you want. That being said, you also need to add stuff here for when the player gets the card and how you display it. You should also change this stuff up here because this finds it based on the number and the suit. You can change these to your own data variables. So maybe it's color and type, which is what I use for Uno. And then the last place that you'll need to edit, that's pretty much it. That's all you edit. You have to add, I mean, those three kind of places are the main places that you need to edit to make sure it works. That doesn't need to be there. But if you guys thought that was useful, make sure to leave a like, please. I almost died trying to make this. I did not even prepare. But it turned out pretty well because I've done decks of cards at least 10 times now. Other than that, some extra stuff. I made a video before this talking about Among Us. I don't think I'm going to be making it anymore just because I did everything that I felt like I wanted to do with it. It got really difficult. I did learn a lot about the tell raw menus. Like I made a generator for myself. I might finish it at some point, but it's just not entertaining to me. It's a lot of Tell Raw crap. I am working on some more things. I was thinking of doing kind of a tabletop simulator for my server so we can play like a ton of games. You know, you do whatever board game or card game you want to play. Anyways, other than that, thanks for watching, and I'll see you next one. Peace.